A stellar city switches on when a straight, luminous bar digs its gravitational oars into the disk and begins to move angular momentum outward like a conveyor. Gas that once circled lazily now meets the bar's leading dust lanes as oblique shocks. It cools, compresses, and slips inward along curved streamers, gathering at resonances where orbital families change character. At a kiloparsec scale, a ring kindles, H2 knots ignite in sequence, then overlap into a running fire that traces the oval-like embers on a fuse. Deeper in, between the inner Lindblad resonances, orbits rotate 90 degrees and the flow stalls just long enough for self-gravity to bite. Tumors Q dips, sheets fracture into filaments, filaments bead into clumps, and the clumps shear into hundreds of embryonic disks, quiet centrifuges where dust settles, pebbles drift, and the first kilometer-scale bodies begin their bookkeeping. The bar is not decoration, it is a torque machine, and every parsec it pulls inward feeds both a central starburst and the slow assembly line of planets. You can almost read the physics in the image, a bright, rectangular spine, two offset, smoky lanes where shocks live, interior arcs of gas curling like river mouths toward a calm inner pool stippled by protodisks. This pump is not steady, it comes in breaths. When inflow peaks, feedback is fierce, winds, ionizing light, and supernovae drill chimneys through the ring and spray metals over the inner disk. It is a spectacular, hazardous hour, great for enriching solids and seeding magnetic fields, terrible for fragile atmospheres. Then the engines sag. After tens to a few hundred million years the radiation field softens, turbulence decays from supersonic to merely brisk, and the sound speed falls enough for thinner midplanes and stronger pressure bumps. Migration traps appear where dust back reacts on gas, snowlines sharpen, dead zones switch on in the cooler inner few astronomical units, reducing viscous stirring. This is the window the bar secretly builds, a lull after the blaze when disks are metal-rich and long-lived, but the sterilizing fireworks have moved on or upward. Around K and late G-type suns nested in the ring's aftermath, warm orbits stabilize, periods of a few tens to a few hundreds of days where water can persist if the atmosphere is not flayed. Giant planets, grown fast by pebble accretion in the metal-heavy outskirts, stall at pressure maxima instead of plowing inward, sparing the inner architectures. The probability of temperate survivor spikes not during the roar, but in the eddy that follows it. Meanwhile the bar evolves under its own labor. Each parcel of gas that loses angular momentum to dive inward hands that momentum to the bar and outer disk, and dynamical friction with the halo slows the pattern until resonances march outward. If inflow is copious, a compact central mass builds and begins to undermine the very orbit family that props the bar up, buckling thickens the spine, sometimes an inner, faster bar sprouts like a relay baton to carry gas the last few hundred parsecs. These cycles write a secular biography, torque, inflow, ring, burst, lull, renewal, each pass flattening metallicity gradients, carving new rings, and resetting the odds for calm climates. Even a mild black hole episode can be folded into the cadence, a short, dim accretion flicker when gas kisses the last resonant barrier, more nuisance than apocalypse for life if it is brief and off-axis. From far away the scene reads as cinema without neon, a barred disk blazing along its axis, two pale rivers of gas pouring inward, and a grainy inner commons where newborn systems glow in thermal reds and amber whites, hundreds of small, hot crescents etched against a darker floor. But under that spectacle runs a careful ledger. Bars are engines that exchange order for structure, they compress entropy into stars and sort solids into disks, they open and close habitability windows on 100-million-year dials. Call them pumps of life not because they guarantee it, but because they sculpt the only conditions under which it can quietly take root and keep its balance while the galaxy catches its breath. Watch the bar long enough and you see it teach the disk to breathe. Spiral arms latch onto its ends like sails, amplifying the bar's pull on the gas and feeding back a tide that keeps the pattern alive. At corotation, where stars orbit with the bar's speed, orbits crowd and then thin like traffic around an on-ramp. Outside, the bar hands energy to the arms and they carry it downrange. Inside, the bar steals energy and the gas surrenders height and radius. Oblique shocks along the leading lanes turn orbital elegance into heat and density, and chemistry follows suit. Carbon chains grow longer, ices flash to vapor and back again, and dust mantles acquire metal skins that make pebbles stickier the next time collisions try to grind them down. The inner ring that seems decorative in a postcard is actually a slow collider, a racetrack where clouds overtake, bump, and merge until they have no choice but to collapse. The sequence repeats, but never exactly. The bar precesses, the halo tug drifts the pattern speed, and every cycle leaves behind a slightly rounder center with a disky, rotation-supported bulge that remembers the bar even if the bar itself fades. Inside the newborn systems, the flow is just as directional. Pressure traps at snowlines and at the edges of low ionization dead zones act like one-way gates, catching millimeter grains and turning a thin dust soup into stripes of abundance. Streaming instabilities wake when solids pile high enough, and gravity finishes the job, knotting pebbles into planetesimals in a geological blink. In high metallicity disks born from bar-fed gas, cores fatten quickly, but the same pressure bumps that helped build them also stop their drift, holding would-be giants in check before they bulldoze the inner real estate. Magnetic fields, stretched by shear and threaded by newborn currents, braid the gas and seed weak winds that carry away just enough angular momentum to keep accretion smooth without shredding the midplane. The ultraviolet glare that once sterilized the ring now flickers from farther out, filtered by dust and chimneys, cosmic rays that spike during the burst decay with their short-lived sources, and ionization settles into a patchwork that favors layered, stable atmospheres over stripped, bare rock. The central engine, if one lights, tends to whisper rather than scream during the quiet turn. A modest, dusty accretion episode can illuminate the last few hundred parsecs and inflate a warm molecular wind that scours the cavity without punching a hole through the disk. It is an odd kindness, a nudge that clears the innermost gas reservoir before it can overfeed the next burst, buying the ring a longer, softer afterglow. In that afterglow, water delivery becomes choreography rather than chaos. Icy fragments from beyond the snowline are jarred into slow diffusion by bar-driven resonances. Weak, secular tugs sweep them inward over millions of orbits instead of hurling them in a single storm. Each impact writes a small, survivable chapter into an atmosphere's ledger, and escape speeds, now unthreatened by nearby giants, keep what is gained. Even failure carries information. Bars that grow too efficient build a central mass concentration that sabotages the very orbits that support them. The spine kinks, the pattern softens, and for a while the disk coasts on memory. Yet the outer disk, ripe with fresh asymmetries and a halo still willing to lend torque, can spawn a new bar that inherits the lanes and restarts the pump. Every rebirth rethreads metal through the inner few kiloparsecs and repaints the gradients that planets later mine. The clock for habitability windows is tied to these secular beats, a luminous season of compression and noise, a tempering season of assembly and cooling, and then a long, dim plateau where orbits settle, atmospheres thicken, and surfaces learn the rhythm of their stars. From the right vantage the whole story fits in a single frame. A graphite bright spine bisects the disk, two smoky rivers of gas pour inward along offset lanes, within, a muted oval pools with light, stippled by hundreds of hot crescents, protodisks catching fire where dust piles and cools. No neon, just thermal glow and scattered starlight, the color of iron at first heat. But the still image understates the intrigue. The bar is exchanging angular momentum for options, trading disorder for scaffold, writing temporary truces between gravity and feedback so that chemistry can slow down and try ideas. Not every cycle will gift a climate, not every ring will raise a stable archipelago of worlds, yet the odds change precisely because the bar keeps time. In a universe where chance rules the small scales, a straight bright scar across a spiral can be the closest thing to intention you will ever see. Tilt the frame and the geometry explains the timing. Two families of closed stellar paths crisscross the inner few kiloparsecs, the long, bar-aligned streamlines that carry most of the torque, and the short, perpendicular loops nested near the center. Gas cannot follow crossing orbits without colliding, so it chooses, it rides the long tracks until the inner resonances, then swings onto the short ones and piles up where the switch is smoothest. That is why the star-forming oval sits just inside the dust lanes and why the hottest newborn clusters march like pearls with an age gradient around the ring, compressed first at the contact points, older downstream as feedback hollows their cocoons. Offset tracers tell the same story in different languages. CO peaks where the squeeze is fresh, H-alpha and P-alpha flare a little further along, warm dust glows still later where winds and radiation have cleared the skin. If you map polarization, you catch magnetic fields draped along the shocks like pulled taffy, then curling inward with the streamlines. If you listen in radio continuum, you hear the flattening of spectra where fresh electrons are stirred and the softening halos where they age. Bars do not only feed, they also edit. By shuttling the cold phase inward, they starve the mid-disk and replace patchy chaos with orderly shear, shutting off giant cloud formation along the bar itself while igniting it at the ring. Quenching and triggering, written side by side on the same canvas. The metallicity slope flattens as recycled material is mixed toward the core, dust-to-gas ratios rise, the opacity of disks born in this season jumps just enough to cool midplanes efficiently and widen the safe corridor for solids to settle. In those opaque nurseries, turbulence declines from roar to whisper, the Stokes numbers that control drift slip into the sweet spot, and streaming instabilities switch on in thin, contiguous bands that ladder up from pebbles to mountain-sized seeds. The same secular torques that once threatened to drag giants inward now carve pressure dams that hold them, confining their gravity wells to the outer workyards and preserving the quiet inner lanes where smaller worlds assemble. Time itself becomes a parameter you can almost measure in the light. When the pattern speed sags, corotation migrates outward and the ring follows, leaving behind a fossilized, rotation-supported pseudo-bulge that still remembers the bar in its flattened, disky kinematics. Catch a galaxy mid-breath and you may see a nested relay, an inner, faster bar turning inside the older one like a gearbox, to fairy gas the last few hundred parsecs. Catch it later and the relay is gone, the central mass has risen just enough to undermine the backbone orbits, and the bar relaxes into a softer oval while the disk regathers asymmetries for the next attempt. Each loop of the cycle redraws the odds for climate, noise, then nurture, then a plateau long enough for oceans to equilibrate and for atmospheres to learn local weather instead of warfare. Even the rare hazards lean toward nuance. A compact black hole flicker fed by the bar's last inward gasp can loft a warm molecular breeze that dusts the cavity and trims the fuel line without blasting the ring. Super winds from clustered supernovae prefer the minor axis, venting perpendicular to the plane and sparing the sheltered inner few hundred parsecs. The net effect, more often than not, is housekeeping rather than catastrophe, an enforced pause that lengthens the calm between bursts. In that pause, water finds its routes through damp snowlines, organics survive UV long enough to polymerize, volatile budgets become a book that can finally stay balanced. Pull back to the promised visual and the physics keeps its elegance. A straight, iron-hot spine bisects the disk, two smoky rivers pour along offset lanes, inside them an oval pool of light is stippled by 100 tiny crescents, protodisks warmed from within, not painted by neon, each a slow centrifuge weighing futures. The intrigue is in the motion you cannot freeze, angular momentum flowing outward, metals and dust flowing inward, feedback venting upward, chemistry settling downward. Call the bar a pump if you like, what it really sells is time, hard-won, locally ordered, statistically generous time, so that a restless galaxy can occasionally host something patient enough to call the result a season and the season a home. Across cosmic time the bars offer changes. Early disks were hot, clumpy, and thick, torques came from massive knots that crashed inward and burned bright, a fast, violent way to feed centers. As universes aged and disks cooled, long-lived spines took over. The fraction of galaxies with strong bars climbs in the nearby epoch, just when metallicities are higher, dust is more abundant, and disks can hold a rhythm instead of a riot. That shift matters because the warm window is not just about distance from a star, it is about the background pace. Bars deliver gas in pulses and then dim, and late-time bars tend to dim into quieter neighborhoods, UV fields down, cosmic ray pressure softer, turbulence subsonic, conditions that lengthen disk lifetimes and let atmospheres keep what they earn. You can test the storyline in light that cares about motion. Along each dust lane the shock bends starlight and reddens it over scales of only tens of parsecs. Just inside, CO filaments curl into the ring, and a few hundred parsecs further along, P-alpha and Br gamma beads flare where clusters have just shed their cocoons. Farther yet, warm dust glows at 24 micrometers as supernovae start to clear the skin, and non-thermal radio brightens where electrons are still young. Outer rings at the bar's far resonance hang like faint halos, signposts that angular momentum has been parked at the rim. Map polarization and you watch fields combed flat along the lanes, then corkscrewing inward with the streamers toward a circumnuclear disk the size of a small galaxy's downtown. Each tracer is a clock, read enough of them and the cadence of burst and lull resolves like a double heartbeat. Under the hood the bar writes small rules that become large outcomes. Pressure bumps at opacity and snowline transitions trap solids. Rossby waves at the edges of those bumps spin up vortices that warehouse pebbles. Ambipolar diffusion and weak ionization clip the wings of magnetorotational turbulence just enough to keep midplanes thin. Streaming instability wakes once solids load the gas to the right fraction, and kilometer bodies appear quickly enough to outrun drift. In bar-fed, metal-rich disks, cores grow but stop at the traps they helped create, and hot Jupiters that would have bulldozed inner real estate remain marooned at safe distances. Photoevaporation, once a scythe in harsh starbursts, turns into a gardener. Disk winds peel only the lofted froth, leaving the dense midplane to finish its slow centrifuge. Even the hazards tend to be directional rather than absolute. Bar buckling heats orbits vertically for a spell and thickens the spine, but most feedback vents up the minor axis, away from the ring and the nestled systems inside it. Modest black hole flickers lift warm molecular breezes that dust the cavity and trim the inflow instead of detonating it. A compact central mass can weaken or even dissolve the bar for a time, and that sabbatical itself becomes a gift, a longer plateau of ordered gas, weak tides, and durable climates before the next relay sprouts. Pull the camera back to the promised scene and the physics stays legible without neon. A graphite bright beam cuts the disk. Two smoky rivers of gas pour along offset lanes toward an inner oval that shines like a low ember. In that oval, hundreds of tiny crescents glow, protodisks catching their own heat, some ringed, some striated, most tilted a little by the local shear. The arms hitch to the bar's ends and ferry energy outward, metals, dust, and stories stream inward. Between those crossings lies the interval that living chemistry likes, not silence, but a steady hush after thunder, long enough for oceans to find levels and skies to learn weather. The bar didn't make life, it made time with a preference, and in a restless galaxy, preference is the closest thing to mercy. Zoom closer and the age gradient turns into a time-lapse. Clusters at the contact points carry blue, hard light and sharp H2 shells. A quarter turn downstream the light warms as winds hollow the cocoons, another quarter and supernovae have carved chimneys that vent vertically, leaving behind calmer, redder knots that fade into a dust-rich oval. The elongated core keeps feeding the loop with fresh gas, but not uniformly. Its torque slackens and tightens as the pattern precesses, so the ring lights in patches that migrate like weather. Magnetic fields ride the flow, combed flat along the shock lanes and then spiraling inward, and their tension helps stitch filaments that refuse to shred. The result is order without stillness, streams that curve, clouds that merge, a racetrack where collisions are frequent but low speed, exactly the kind of traffic that favors collapse over carnage. In that inner commons the new systems inherit a chemical dowry that is richer than the mid-disk average. Dust mantles thicken, volatile ices cycle between vapor and frost, and grains accrete metal skins that make them tacky enough to glue on contact. Pressure traps at opacity jumps and snowlines collect solids into narrow belts. Rossby eddies at the belt edges hoard pebbles, streaming instabilities wake and promote piles into kilometer seeds before drift can steal them. Cores climb the mass ladder quickly, but the same pressure dams that built them also act as brakes, catching would-be giants before they surge inward and overturn the inner lanes. With the glare from massive neighbors already tapering and the cosmic ray bath relaxing after the burst, atmospheres that condense on these worlds stand a chance of keeping what they gather. The warm corridor, weeks to months of orbital period for modest suns, stops being a knife edge and widens into a shelf. The straight axis also edits the disk beyond the ring. Along the stellar bridge itself, shear is high and turbulence is oddly disciplined. Giant clouds struggle to survive there, so star formation skips the spine and blooms at its ends and inside its oval. That division of labor writes two signatures at once, quenching in the bar proper, ignition at the resonances. Over repeated cycles the process flattens metallicity gradients and fattens a rotation-supported central component that remembers the bar in its kinematics even if the spine weakens. When the pattern slows, corotation marches outward and the outer ring at the far resonance grows, faint, broad, and metal-mixed, a record of where angular momentum was parked. The inner ecosystem keeps most of the benefits, a steady inflow, a softening background, and long, relatively quiet intervals where disks live out their viscous clocks. Hazards remain, but they acquire direction and timing. Bar buckling heats stars vertically for a season and thickens the spine, yet most feedback still vents up the minor axis, sparing the plane. A compact central flare, if the inflow briefly kisses the last resonant barrier, tends to be dusty and local, more of a warm molecular breeze than a scouring blast. Even encounters help more than they hurt. A passing dwarf or a tidal nudge can strengthen the stellar truss, freshen the lanes with new fuel, and reset the cadence without erasing the inner order. The worst outcomes require bad luck and bad phasing together. The typical outcome is housekeeping that lengthens the lull that chemistry prefers. Look again at the promised frame and the physics stays readable. A graphite bright beam runs through the disk, two smoky rivers descend along offset lanes, inside, an oval pool glows like banked coals. Across that pool, hundreds of tiny crescents shine, protodisks lit by their own friction and by warm dust, some laced with rings where pressure has penned the solids, some showing bars and spirals of their own where self-gravity has begun to write smaller copies of the larger script. Nothing garish, just thermal light and scattered starlight, the palette of iron at first heat and dust near sublimation. Follow the money, the angular kind, and the ledger explains the odds. The elongated hub steals angular momentum from gas and gifts it to stars outside, the arms carry that gift outward, thinning chaos at the center, the ring spends the inflow on clusters and on the quiet machinery of planet building, feedback pays a tax upward and buys clearer skies, the pattern slows and the cycle resets. Each loop is a negotiation between gravity, dissipation, and memory. None of it guarantees a climate, but it stacks probabilities in a way that blind, unbarred drift rarely does, more metals where you need them, less turbulence when it counts, pressure traps in the right places, and time, precious, statistically unusual time, for oceans to find their level and skies to learn stable weather. Even failure leaves useful fossils. A spine that grows too efficient can undermine its own orbit family and relax into a softer oval. What remains is a flattened, fast-rotating center with a dust-rich ring that still does the job. A lull that stretches into 1 billion years cools the background far enough that thin disks survive long after their luminous parents fade. A late relay, a short, faster inner bar, can reignite the lanes and finish the delivery to a tiny circumnuclear disk without waking a full storm. The script is modular, and galaxies rewrite it with local accent, but the theme holds. A straight scar across a spiral rearranges chaos into cadence and trades brightness now for survivability later. From that vantage, calling the bar a pump is not metaphor but mechanics. It takes disordered orbital energy and exports it, it concentrates raw material where orbits are kind, it opens a window after thunder when the midplane is cool, the radiation polite, the chemistry unhurried. If life anywhere needs a patient hour in a restless city, a luminous spine across a disk is how the city buys it, an engine that prefers sequence over spectacle and builds, in its pauses, the possibility of a home. Tip the lens to the outer disk and you catch the other half of the bargain. At the bar's far resonance the traffic circle widens into a faint, gauzy ring where angular momentum is parked like cargo at the rim. Clouds there are stretched, not crushed, star formation is patchy, slow, and metal poor compared to the inner oval. That contrast matters. The outskirts remain a cold reservoir feeding the next innings, while the center refines and assembles. A minor tidal nudge, an offhand brush from a passing dwarf, can straighten the spine, tighten the lanes, and send a fresh pulse inward without igniting a full storm. Secular evolution becomes choreography, energy shuttled outward, mass ferried inward, pattern speed easing down, resonances stepping to new radii, and the whole system learning a slightly different rhythm with every lap. Inside the ring, kinematics whisper how gentle the favorable seasons are. Velocity dispersion drops in the midplane, not to silence but to a hush that lets grains settle. Epicycles still exist, yet their swirls are small enough that pressure bumps hold their cargo. Ionization stratifies, tenuous skin active and windy, dense belly cool and calm. Ambipolar drift slides fields through neutral gas like hands through silk, diffusing just enough magnetic stress to keep shear from shredding the midplane. Chemistry exploits the lull. Carbonates condense at warm borders, organics polymerize instead of pyrolyzing, sulfur cycles without erasing water. The inventory that worlds need, volatiles, metals, catalysts, arrives in proportions that make geologies varied and skies stable, the two conditions most correlated with long-lived surfaces. Closer to the spine, the stellar backbone edits orbits in 3 dimensions. A brief buckling phase lofts stars above the plane and leaves behind a peanut-shaped kernel whose rotation still remembers the bar's cadence. Stripped of much of its cold gas, the spine becomes a truss rather than a nursery. It carries torque, not cradles. That division of labor is why the postcard shows emptiness along the bar and fireworks at its ends and inside its oval. Quenching and ignition sharing a single mechanism is not a paradox but a feature, the same ordered shear that forbids giant clouds in the bridge hurls gas toward resonances where collapse is inevitable and productive. Not every relay ends softly. A central mass can grow steep enough to scramble the orbit family that props the spine, and the bar will relax into an oval. Yet the fossils it leaves, the flattened, rotation-supported core and the mixed metal inner few kiloparsecs, keep doing the quiet work. They mint clusters, host long-lived disks, and buffer feedback so that the next pulse arrives as rain rather than hail. When a short, faster inner bar sprouts, it is a whispering gearbox, not a siren, a few hundred parsecs of extra torque that finishes the delivery without bringing back the thunder. Those episodes, stacked over hundreds of millions of years, are how a restless galaxy writes patient chapters, intervals long enough for climates to equilibrate, oceans to redistribute heat, and atmospheres to learn local weather instead of surviving local war. Frame the scene once more and let the intrigue sit in the physics you can nearly see. A straight, iron-bright scaffold bisects the disk, 2 muted rivers of gas curl inward along offset lanes, an inner oval smolders like banked coals, across it, hundreds of tiny crescents glow with their own heat, some ringed where pressure arrests drift, some striated where self-gravity has begun to draft miniature bars and spirals. Energy flows outward, matter flows inward, feedback vents upward, and chemistry settles downward. The elongated hub is not a flourish, it is a preference machine, taking a messy city of orbits and for a while choosing arrangements that favor continuity over spectacle. In those chosen intervals, chance stops feeling alone. The window for temperate worlds widens from a sharp ledge to a gentle shelf, and a spiral with a scar across its heart quietly becomes a better host for time. Statistical hints gather when you stack many barred cities at once. Metallicities run flatter inside the inner few kiloparsecs than beyond, rings host clusters with tidy age gradients, dust lanes stay razor-thin and offset, betraying shocks that never quite sleep. In integral field maps the gas spins on one rhythm while the stars hum on another, and the beat difference marks the pattern speed. Most spines end just shy of corotation, fast enough that arms hitch to the tips and ferry energy outward, slow enough that gas can still feel the pull and slip inward along the leading lanes. Where corotation drifts, the whole orchestra retunes, the ring walks, the contact points migrate, and last year's hotspots cool into today's red knots. Follow the manifolds around the bar's saddle points and the traffic plan pops into view. Trajectories that graze the Lagrange gateways peel into streams that either escape to the arms or spiral down toward the inner oval. Dust rides these highways like smoke tracing wind, announcing every bend with a kink and every shock with a sharp, dark edge. Inside the inner resonances, the closed family of short, central loops, those perpendicular orbits that gas prefers once the geometry flips, builds a compact, rotating disk that acts as a staging yard. From there, only a few hundred parsecs remain to the very center, and those last steps are governed by quieter gear, a small, faster relay bar if one exists, spiral dust fingers if it doesn't. Simulations that start messy and gas-rich end up writing the same choreography by themselves. Stir a young disk until it grows a spine, feed it, let feedback blow chimneys, slow the pattern, repeat. Each round trims the metallicity slope, fattens a rotation-supported core, and lengthens the intermission between roars. Crucially, the intermission is not empty. Turbulence decays from supersonic to gently transonic, the sound speed falls, the scale height shrinks, pressure traps sharpen at opacity jumps and snow lines. In that regime, solids stop behaving like free dust and start behaving like freight, captured, warehoused, advanced along belts and vortices until gravity signs for delivery. The exoplanet arithmetic changes with that logistics plan. High solid-to-gas ratios build cores quickly, but pressure dams that form from the same physics keep those cores from stampeding inward. Temperate corridors cease to be narrow ledges and become terraces, weeks to months orbits for modest suns with midplanes cool enough to keep volatiles, warm enough to keep oceans mobile, quiet enough that atmospheres don't boil away in tantrums. Giants still grow, but they loiter at the shelves that raise them, shaping outer climates while leaving inner lanes in peace. When giants do wander, they do so after the burst, through thicker, cooler air, in migrations that reshape but do not raise. The hazards never vanish, they line up. A buckling episode thickens the bar into a peanut-shaped kernel and sends a brief rain of vertical heating through the inner disk, but most of the fury vents up the minor axis. A compact accretion flicker at the very center floods a few hundred parsecs with warm molecular light and then starves, trimming the inflow without kicking the door off its hinges. A passing dwarf tweaks the pattern, freshens the lanes, perhaps even kindles an outer ring at the far resonance that stores the angular momentum the inner city just exported. None of these are guarantees, all of them are biases, small tilts that make the calm last longer than it would by accident. Even the color palette tells on the physics without resorting to neon. Iron first heat at the spine, soot dark at the shocks, ember red in the ring where dust glows and newborn clusters push back their cocoons, faint amber along the arms as they carry the bar's surplus into the outskirts. Inside the oval the crescents multiply, slender arcs where rings and gaps have penned solids, thicker halos where accretion is still hot, occasional bars and spirals inside disks where self-gravity has started to write miniature copies of the grand design. It is a quiet blaze, readable at a glance and inexhaustible on closer inspection. Time scales stack like nested clocks. Tens of millions of years for a ring to light and drift, hundreds of millions for a pattern to slow, a relay to sprout, or a spine to relax, a billion for gradients to flatten into memory and for a rotation-supported center to take on a life of its own. Habitable intervals sit between these gears, longer than the flare of a single burst, shorter than the death of the pattern, long enough for oceans to equilibrate and for skies to invent weather instead of survive it. What bars sell, in the end, is not certainty but duration, ordered stretches in noisy neighborhoods, stretches in which chemistry can finish sentences it usually has to abandon. If you want a field test, listen in multiple languages at once. CO maps flag the fresh squeeze, recombination lines mark the cohorts that just came of age, mid-infrared bands from aromatic carriers trace the relit skins after shocks, radio continuum hardens where electrons are new and softens where they have aged, polarization lines up along lanes and then spirals inward with the flow. Lay those tracers over the starlight and the cadence appears like a heartbeat with a pause between beats, a pulse and a rest, delivery and digestion. Pull back once more to the promised frame, a straight, luminous truss cutting the disc, two muted rivers pouring inward along offset lanes, an inner oval glowing like low coals, across it, hundreds of hot crescents, small laboratories spinning down their chaos into structure. Energy leaves, matter gathers, winds climb, chemistry settles. Call it a pump if you want, it is equally a metronome. In a universe that prefers turbulence, a bar persuades a spiral to keep time, and in those counted measures the odds tilt, slightly, stubbornly, toward worlds that can warm without burning and last long enough to remember. Tip the simulation a notch further and the mechanics read like a recipe. The long, bar-aligned orbits, call them the spine family, carry most of the torque. The short, perpendicular loops inside, call them the heart family, collect the inflow. Gas, forbidden to cross itself without shock, slips along the spine until the inner switches appear, then folds onto the heart loops and stalls just long enough for gravity to steal the show. There, surface densities clear the instability threshold, sheets shred into filaments, filaments bead into clumps, clumps shear into hundreds of compact centrifuges that glow as pale crescents against a warm floor. Dust mantles thicken, ices cycle at their snow lines, and pebbles drift until pressure traps at opacity jumps and dead zone edges hold them like shelves. Vortices bloom at the trap rims, streaming instability wakes, kilometer bodies appear before drift can rob the bank. The same pressure dams that built the cores catch them, too, and what might have become marauding giants hangs back on the outer terraces, leaving the inner lanes to sketch smaller, tempered plans. Observables keep the ledger honest. Dense gas tracers spike just inside the dust lanes, shock fingerprints in CO and Fe2, sharpen where the squeeze is young, recombination lines bead slightly downstream, PAH bands reignite further yet as skins recover, radio spectra harden where electrons are fresh and soften where they age, polarization vectors lie flat along the lanes and then spiral into the oval. Pattern speed sets the cadence. When it sags, corotation walks outward, contact points migrate, and the ring's hotspots drift like weather on a slow jet stream. Outer arms hitch to the bar tips and ferry energy outward, raising a faint far ring that warehouses angular momentum at the rim, inner flows curl inward like smoke following a draft, and the downtown fattens into a fast-rotating kernel that remembers the spine long after it fades. Habitability is a matter of background manners. During the roar, UV fields, shocks, and cosmic ray baths are blunt instruments, excellent for chemistry's inventory, cruel to young atmospheres. In the lull, the atmosphere of the inner few kiloparsecs turns civil. Turbulence slides from supersonic to transonic, sound speeds fall, scale heights shrink, ionization stratifies into a windy skin and a cool belly, ambipolar drift bleeds magnetic tension without tearing the midplane. Disk winds peel froth and leave the dense waste to work, photoevaporation trims, not scythes. Metallicity and dust-to-gas ratios sit in the sweet spot where midplanes cool efficiently and pressure bumps stay sharp. The Corridor 4 warm orbit ceases to be a cliff and becomes a shelf, weeks to months periods around modest suns where water can stay liquid, volatiles can cycle, and skies can keep what they are given. The bar edits architecture beyond the ring as surely as it feeds the center. Sheer along the stellar truss is high and disciplined, giant clouds seldom survive on the bridge, so star formation leaps to the ends and into the oval. Quenching and ignition share a cause, ordered torque that forbids one locale while forcing collapse in another. Over cycles, gradients flatten, a rotation-supported core fattens, and the intermissions lengthen. Even interruptions lean helpful. A short, dusty nuclear flicker lifts a warm molecular breeze that vacuums the cavity and chokes the inflow before a full storm can form. A mild buckling season thickens the spine yet vents fury up the minor axis, away from the cradle. A passing dwarf tweaks pattern speed just enough to refresh the lanes without wrecking the stage. Cinematically, nothing gaudy is required. A graphite bright beam cuts the disc, two smoky rivers stream along offset lanes, inside, an oval smolders like banked coals, across it, hundreds of crescents glow, some narrow with rings where pressure pens solids, some thicker where accretion still runs hot, some already sketching tiny bars and spirals of their own. Energy flows outward, matter flows inward, winds climb, chemistry settles. The intrigue is in the invisible current, angular momentum traded for options, noise traded for cadence, brightness now traded for survivability later. A bar does not promise life, it sells duration, measured, statistically generous seasons in which disks can finish their bookkeeping, oceans can find level, and skies can practice weather instead of war. In a universe that prefers turbulence, a straight luminous scar persuades a spiral to keep time, and in those counted measures you can almost hear probability tilt. Push the clock forward one more beat and the city redraws its lanes. As the pattern slows, corotation migrates and the contact points slide, the ring does not switch off so much as relocate, leaving behind a fossilized, rotation-supported kernel with disky kinematics and a memory of straight lines. The fresh oval lights where the new inner resonances settle, and the same choreography resumes with a different radius, shocks along the leading lanes, dense gas spikes just inside them, age gradients that march around the oval like hours on a dial. Between these resets the background manners improve, radiation fields soften, turbulence tapers, and the midplane compresses, so the next cohort of disks begins with higher metallicity, sharper pressure traps, and gentler stirring. The corridor for temperate orbits thickens from a ledge to a terrace, and cores that would have plunged inward in a riot now meet pressure dams that stall them into quiet architecture. Habitability, in this script, is an emergent property of patience. The bar manufactures patience by turning violent inflow into paced delivery. Zoom into a single crescent and the small physics rehearses the large. Pebbles drift inward until a snowline or opacity jump slows the gas and creates a shelf, solids pile, vortices bloom, streaming instabilities wake, planetesimals appear before drift can bankrupt the account. Ionization stratifies so that a windy skin can vent while a cool belly stays laminar, weak magnetized winds bleed angular momentum without shredding the midplane. Young atmospheres condense while the fireworks are already venting up the minor axis and away from the plane, cosmic ray baths that once scoured the ring slacken with the dying burst, and escape velocities begin to win. Giants still grow in the outer workyards, but the same shelves that raised them keep them there. Inside, months-long orbits around modest suns stop living on a knife edge and learn weather. The promised image remains honest without neon. A straight, iron-bright truss spans the disk, two smoky rivers of gas stream along offset lanes, within, an oval pool glows like banked coals. Across that pool, hundreds of tiny crescents shine, some narrow and ringed where pressure has penned the freight, some fat and veiled where accretion is still hot, a few already sketching miniature bars and spirals under their own self-gravity. Angular momentum leaves by the arms, metals and dust arrive by the lanes, feedback climbs out of the plane, chemistry settles to the midplane. The intrigue is the ledger you cannot see, torque converted into structure, brightness spent to buy duration, chaos negotiated into cadence. A bar does not guarantee life, it engineers intervals in which life is statistically less unlikely, carving seasons of gentle background in a city that otherwise prefers storms. In a universe that loves turbulence, a straight scar persuades a spiral to keep time, and in those counted measures, worlds get to try ideas long enough to remember them. Tip the telescope to chemistry and the lull sharpens into a laboratory. The inflow salts the inner kiloparsec with fresh metals and dust, so cooling times shorten and clouds reach higher densities before feedback can bite. Grain mantles cycle through frost and vapor at snowlines that now sit closer to the star, plating pebbles with sticky skins and raising the collision efficiency that turns sifted dust into freight. Carbon chains survive shocks better when the background UV is down, nitriles and simple alcohols last long enough to seed the next steps, sulfur stops behaving like a vandal and starts acting like a catalyst. The midplane, thin and slightly magnetized, becomes an assembly belt with built-in quality control, pressure shelves pin the inventory, vortices warehouse it, and weak winds keep the belt moving without rattling the cargo. Kinematics sketch the quiet in numbers that feel like weather. Velocity dispersion sag to the low tens of kilometers per second in the gas, shear remains high where it should, along the stellar truss, but inside the oval the flow curves, not clashes. Oblique shocks at the lanes still right crisp edges, yet just inside, line widths narrow and the rotation curve turns velvet smooth. Pattern speed sets the tempo. As it eases, the resonance radii walk outward and the ring follows, the contact points drifting like a slow front across a continent. Each relocation inherits a richer mixture, flatter abundance gradients, higher dust to gas, so every new cohort of disks begins a little cooler, a little stickier, a little better at holding on to what matters. Architecture responds with restraint. In the outer workyards, cores fatten quickly on pebble diets, but pressure dams that helped build them also arrest their march, leaving would-be giants loitering where they sculpt climates without raising inner streets. Inside, months-long orbits around modest suns graduate from knife edge to terrace, enough irradiation to keep oceans moving, not enough tantrum to boil skies. Dead zones bloom at the right radii to mute turbulence without stopping accretion, magnetized breezes peel only the froth and spare the dense waste where atmospheres thicken. A skyline of small worlds is more likely than a few bullies, multiplicity replaces melodrama. The stellar backbone keeps editing the city as it feeds it. Along the bar proper, ordered shear suppresses giant clouds, star formation dodges the spine and blooms at its tips and in the oval it supplies. Quenching and ignition read as opposites in photographs and as cause and effect in dynamics. Over cycles, the center flattens into a fast-rotating kernel that remembers straight lines in its orbits even after the truss softens, metallicity slopes level, the intermissions lengthen. A mild buckling season thickens the spine into a peanut-shaped core and vents heat up the minor axis, away from the cradle. A dusty central flicker trims the fuel line rather than detonating it, buying the ring a longer, softer afterglow. Even the outskirts take a role that makes the whole sustainable. At the far resonance, a faint outer ring stores the angular momentum the bar exported. It is a reservoir that keeps the inner pump from starving and a brake that keeps the pattern from racing. Arms hitched to the bar tips ferry energy outward like tethers, small asymmetries, refreshed by tides or lopsided accretion, keep the spine honest. When the pattern slows too far and the orbit family that props the truss begins to fail, the city coasts on its rotation-supported memory until a new relay sprouts. Secular evolution is not a single event, it is a habit. Observables line up like instruments in an orchestra you can hear with the right receivers. Dense gas tracers spike just inside the dust lanes, shock fingerprints sharpen at the kinks, recombination lines bead along the ring with a clean age gradient. Mid-infrared bands relight the skins after the squeeze, radio spectra flatten where electrons are fresh and soften where they age, polarization vectors lie along the lanes and then twist inward with the flow. Stack those maps and the cadence appears, delivery, digestion, delivery again, each beat slightly slower, each rest slightly longer, each cohort of disks beginning under gentler manners. Drill down to a single crescent and you still find the bar's signature. Rings and gaps mark where pressure has penned the freight, a soft wind lifts only the high-altitude chaff, the laminar belly carries pebbles inward until a snowline arrests them and a vortex banks the pile. Streaming instabilities wake at the right load, kilometer seeds arrive before drift can embezzle the account. Cores assemble, atmospheres condense, and the fireworks that once threatened them now vent orthogonal to the plane. The difference between catastrophe and climate is rarely a new ingredient, it is timing. The truss manufactures timing. Pull back to the frame and nothing garish is required. A straight, iron-bright scaffold cuts the disc. Two smoky rivers of gas pour along offset lanes. An inner oval smolders like banked coals. Across it, hundreds of small crescents glow, thin where pressure pens solids, thick where accretion still runs hot, a few already showing miniature bars and spirals under their own gravity. Energy leaves by the arms, matter gathers by the lanes, winds climb out of the plane, chemistry settles to the midplane. Call it a pump, a metronome, an auditor, it trades angular momentum for options and brightness now for duration later. In a universe that defaults to turbulence, a luminous scar persuades a spiral to keep time, and in those counted measures the odds tilt, quietly and persistently, toward worlds that can warm without burning and last long enough to learn their own weather. Turn the camera into prediction mode and the script starts offering tests. If bars really manufacture patient seasons, then ring-borne systems should skew toward compact, multi-planet architectures with low eccentricities and modest mutual inclinations, chains that hint at pressure shelves and gentle migration rather than bull-in-a-china shop giants. Hot Jupiters should be rarer for these cohorts because the same dams that helped fatten cores also stalled inward rush. Warm giants marooned at exterior traps should be the typical heavyweights, shaping climate from afar instead of raising inner streets. Atmospheres on inner small worlds should carry the signature of a tempered nursery, higher metal hydrides early, then a slow tilt toward water and CO2 as photoevaporation eases and delivery trickles in across cooled snowlines. None of this requires miracles, it only requires a background that calms down on schedule. Observables line up in layers that cross-check each other. Steeper age gradients along the inner ring than along the arms, but with softer UV fields a quarter turn downstream, dense gas tracers spiking just inside dust lanes, then a clean handoff from H2 lines to warm dust bands to non-thermal radio as clusters mature, polarization vectors combed along shocks and spiraling inward across the oval, metallicity slopes flatter in the inner few kiloparsecs than beyond, with dust-to-gas ratios just high enough to sharpen pressure shelves. Stack those maps over stellar kinematics and the pattern speed drops out of the difference between the gas beat and the star beat. Watch that speed sag across a sample and the resonances should walk outward with it, pulling the ring and its age dials along like a tide. Drill back into the crescents and the microphysics echoes the verdict. Streaming instability does not need heroics when solids are pre-sorted, vortices at shelf edges warehouse pebbles, magnetized breezes lift only froth, and the midplane, thin, cool, slightly ionized, lets kilometer bodies appear before drift can embezzle the account. Dead zones turn turbulence from roar to murmur without freezing accretion, snowlines plate grains with sticky skins that boost collision efficiency by quiet percentages that compound. Giants still happen, but their wakes are gentler, their migrations later and slower, their final parks at the very shelves that raised them. The inner lanes, spared the stampede, sketch delicate plans and have time to revise them. Even the failure cases teach the rule. A central mass that grows too steep can unravel the orbit family that props the spine, the bar relaxes into an oval and the lanes go soft. Yet the rotation-supported kernel it leaves behind keeps the downtown orderly, and the mixed metal inner disk continues to mint long-lived systems under calmer skies. A buckling episode thickens the spine into a peanut kernel, vents heat up the minor axis, and, counterintuitively, buys the ring a longer intermission. A dusty nuclear flicker trims the fuel line without detonating it. A tidal nudge from a passing dwarf tightens the truss and refreshes the streams. Catastrophe is possible, cadence is common. Run the time-lapse in your head. First beat, a bright truss bites, shocks light the lanes, a ring kindles, clusters bead, chimneys open. Second beat, the background softens, turbulence eases, the midplane thins, crescents multiply and sharpen as pressure pens the freight, warm corridors widen from ledges to terraces. Third beat, pattern speed sags, resonances migrate, the old ring fades into a memory kernel while a fresh oval ignites at a new radius, inheriting better metals and thicker dust. The intervals between beats lengthen. The metropolis is still restless, but its seasons become readable. And the visual you asked for keeps telling the truth without neon. A straight, iron-bright bar cleaves the disk. Two smoky rivers bow inward along offset lanes. Inside, an oval smolders like banked coals. Across that oval, hundreds of tiny, warm crescents, protodisks catching their own heat, some ringed where pressure pens the inventory, some veiled where accretion still runs hot, a few already sketching miniature bars and spirals of their own. Angular momentum flows outward through the arms, metals and dust flow inward along the lanes, winds carry the noise up and away, chemistry settles down. The bar is not a promise, it is a preference. It takes a galaxy that would rather be thunder and teaches it to count to 4, again and again, until chance stops being alone and time, for a while, belongs to worlds that can use it. Push into the nucleus and the geometry tightens. Inside the inner resonances, the short, perpendicular loops knit a compact, rotating disk a few hundred parsecs across. Gas here no longer rides highways, it circles patiently, trading small torques in a viscous queue. If a tiny relay bar appears, it is more gearbox than spectacle, sliding material inward by tens of parsecs per million years. The payoff is incremental but decisive, a circumnuclear disk that feeds clusters in bursts, salts the region with fresh metals, and then idles. During idle the radiation field softens, shear stays orderly, and the thin midplane becomes a chemical workshop where grains plate, stick, and step up the ladder from pebbles to planetesimals on timelines that outrun drift. Read the pattern as kinematics and the cadence falls out. The stars carry one frequency, the gas another, their phase offset is the bar's signature. Apply a continuity trick, the Tremaine-Weinberg method, and the pattern speed drops out without guessing. Watch that speed decline across a sample and you see resonances march outward, old rings fading into rotation-supported memory while new ovals light at larger radii. With each migration, abundance gradients flatten and dust-to-gas ratios edge upward. Every new cohort of disks starts with sharper pressure shelves and cooler bellies, a quiet statistical nudge toward compact, multi-planet systems that hold their atmospheres. Feedback keeps its lanes. Ionizing light and winds carve chimneys that vent perpendicular to the plane. Supernovae prefer the minor axis, even modest black hole flickers tend to couple to warm molecular gas close in, trimming the fuel line rather than scouring the ring. That anisotropy matters. The plane, the only place disks can live, sees housekeeping instead of havoc during the lull. Photoevaporation peels high-altitude froth, magnetized breezes bleed angular momentum without shredding the waste, cosmic ray pressure relaxes as massive stars age out. What remains is a tempered background where snowlines sit steady, dead zones mute turbulence, and pressure bumps keep freight from stampeding. Predictions follow that a sky can test. Inner rings should show crisp age gradients with softened UV a quarter turn downstream. Dense gas tracers peaking just inside dust lanes should hand off cleanly to recombination lines, mid-infrared bands, then non-thermal radio as clusters mature. Polarization should align along shocks and spiral into the oval with the flow. Metallicity slopes should be flatter inside a few kiloparsecs than beyond. Where bars are strongest and pattern speeds have slowed the most, warm giants should loiter at exterior traps, while small worlds in months-long orbits cluster in low eccentricity, low inclination chains, the architectural echo of shelves, vortices, and gentle migration. Return to the promised frame and let it stay understated. A rigid-looking spine crosses the disk, two muted lanes lean forward and feed an inner oval that glows without glare. Across that oval, hundreds of fine crescents tilt at slightly different angles, some ringed where pressure has penned the solids, some thicker where accretion still runs hot, a few already laced with miniature bars and spirals under their own gravity. Energy is being exported by the arms, matter imported by the lanes, noise vented upward, chemistry settled downward. The bar is not a miracle, it is a habit of order in a noisy city, converting torque into structure and brightness into duration until the odds for warm, durable worlds stop being an accident and start being a bias. Tip the galaxy edge on and the bar's handwriting turns into an X, boxy peanut kernels bloom where the spine once buckled, their stars on banana-shaped loops that spend most of their time above and below the plane, leaving the midline to gas that prefers order. Dust lanes that look like gentle brushes in a face-on postcard become razor slashes here, thin and dark, hugging the leading edges where shocks live. The chimneys opened by clustered supernovae red as pale, vertical veils. Between them, the plain looks oddly calm, as if the city learned to vent its anger upward to spare the streets. Even the rotation curve whispers the compromise, a firm rise, a soft shoulder across the bar, and a velvet turn inside the ring where orbits are circular enough for chemistry to keep appointments. Bars speak dialects, and each accent reshapes the odds. A strong, short spine pushes corotation barely beyond its tips, arms weld to the ends and ferry energy outward efficiently, while gas still feels the inner tug and slides along the lanes. A slower, longer spine leaves a larger gap, arms decouple, manifolds wrap into suturings, and the inflow arrives in broader strokes that like multiple contact points like weather. Nested relays complicate the grammar. An inner, faster bar turns inside the elder like a clock within a clock, handing gas inward by tens of parsecs without raising its voice. Where inner resonances split, double rings appear, a bright, tight oval for clusters and a looser lane for staging fuel, two tracks of the same circulation, two clocks ticked by the same metronome. Follow the manifolds around the bar's saddle gates and the traffic resolves into rules. Trajectories skimming the L1 and L2 gateways peel into streams that either leap to the arms or spiral down to the oval. Small changes in pattern speed move the gates and rewrite the map. That is why age gradients migrate around the ring year by slow year, why CO brightens just inside the dust lanes while recombination lines lag by a fraction of a turn, why polarization vectors lie flat along the shocks and then twist into the oval like pulled ribbon. Even abundance carries the watermark. Gradients flatten inside a few kiloparsecs, dust-to-gas ratios rise just enough to sharpen pressure shelves, and every new disk lights with cooler bellies and stickier skins, a quiet compounding that turns probability into habit. Inside a single crescent the same choreography plays small. Pebbles drift, hit a shelf at a snowline or opacity jump, and pile until vortices bloom. Streaming instability wakes when the load crosses a quiet threshold, and kilometer bodies appear before drift can embezzle the account. Ionization stratifies so a windy skin can vent while a cool belly stays laminar. Weak magnetized breezes bleed angular momentum without shredding the midplane. Cores climb mass ladders quickly in this metal-rich air, but the shelves that fed them also anchor them. Would-be giants loiter at the outer terraces and sculpt climates from afar. Inside, months-long orbits around modest suns stop living on a knife edge and learn seasons. Atmospheres condense under muted tantrums, water finds cycles that repeat. Even hazards arrive with timing that favors survivors. A buckling season thicks the spine and lifts heat out of the plane. A dusty nuclear flicker trims the inflow rather than detonating it, leaving a warm molecular breeze as the signature instead of a crater. A passing dwarf at the rim tightens the truss and freshens the lanes without tearing the stage. Catastrophe is an option, cadence is the baseline. Between beats, turbulence drops from roar to murmur, sound speeds fall, scale heights shrink, and the midplane compresses into an assembly belt with built-in quality control. The lull is not empty, it is precise. Pull back to the promised visual and nothing gaudy is needed. A rigid-looking spine cleaves the disk. Two smoky rivers bout inward along offset lanes. Within, an oval smolders like banked coals. Across it, hundreds of fine crescents glow, some ringed where pressure pens the freight, some veiled where accretion still runs hot, a few already sketching tiny bars and spirals of their own. Arms siphon energy to the outskirts, lanes import metals and dust to the heart, winds carry the noise upward, chemistry settles down. Call the bar a pump, or a metronome, or an auditor, it trades angular momentum for structure and brightness now for duration later. In a universe that loves turbulence, a straight luminous scar persuades a spiral to keep time, and in those counted measures the odds tilt, quietly, stubbornly, toward warm worlds that can last long enough to write weather into memory. Tip the lens to asymmetry and another lever appears. Lopsided, one-armed waves drift through barred centers like slow weather fronts, nudging gas off perfect ovals and sprinkling it into the staging yard in gentle, low-mach streams. Nuclear spirals, thin, dusty filigrees nested inside the ring, do the last miles of delivery without raising their voice, handing fuel to a circumnuclear disk in pulses that look like heartbeat noise rather than storms. Each pulse salts the inner few hundred parsecs with fresh metals and dust, shortens cooling times, and resets the chemistry clock without spiking the UV field. The ring answers with clusters born on schedule and with fewer tantrums, and the crescents across the oval sharpen their rims as pressure shelves harden. Architecture echoes that patience. Outer resonances park angular momentum in faint or 1/2 suturings, a break that keeps the spine from racing while the heart keeps its cadence. Inside, the orbit families trade places only where the geometry is kind, so shocks stay confined to the leading lanes and line widths narrow just beyond them. Velocity ellipsoids flatten, dispersion drops to the quiet but not still regime, the rotation curve turns into a smooth shoulder across the bar and a velvet rise inside the ring. In that environment, pebble isolation masses are reached early but not exceeded wildly, cores cap themselves at shelves instead of charging inward, and hot Jupiter archetypes become outliers rather than fate. Warm giants marooned at exterior trapped shaped climates from afar, setting gentle secular beats instead of erasing streets. Time keeps compounding the bias. Each bar breath slows the pattern a touch, walks corotation outward, and lights a new oval at a larger radius with flatter gradients and higher dust to gas. Every new cohort of disks begins a fraction cooler and stickier, with dead zones positioned to mute turbulence without freezing accretion, and with snowlines steady enough that delivery is diffusion rather than hail. Feedback continues to vent up the minor axis, ionized chimneys, warm molecular veils, leaving the plane to bookkeeping. Photoevaporation trims foam, magnetized breezes bleed momentum, ambipolar drift lets fields slide instead of tear. The midplane becomes an assembly belt with quality control. Even endings are constructive. If a central mass steepens and the orbit family that props the spine unravels, the bar relaxes to an oval and the city coasts on its rotation-supported memory, flat fast stars, mixed metals, ordered shear. That sabbatical is a long intermission for climates, fewer shocks, softer radiation, slower cosmic ray baths. A future relay can sprout when asymmetries return, and the cadence resumes with a slightly better hand. From the promised vantage you can still read the whole ledger without neon, a straight, iron-bright truss, two smoky rivers leaning forward, an inner oval like banked coals, hundreds of warm crescents, some ringed, some veiled, a few already sketching tiny bars of their own. Energy leaves by the arms, matter gathers by the lanes, winds climb out of the plane, chemistry settles down. The bar never guarantees a habitat. It manufactures time with a preference, ordered, statistically generous minutes in which disks finish their plans, oceans find levels, and skies learn weather well enough to remember it.